In this video guide, we'll go over the basics of customizing and configuring control schemes for CyberBrick designs using the CyberBrick desktop app.
Part 1. Introduction.
The CyberBrick app is the control center that lets you configure and customize your creations. It works by linking the input modules on your remote to the output modules on your machine. This allows you to control physical movements like driving a vehicle, operating a robot arm, or anything else you can imagine. Inside the remote control, the transmitter board acts as the brain. It connects to inputs like joysticks, buttons, and switches, and it sends out a wireless signal when you move them. Over on the machine, the receiver board picks up that signal. It instantly commands your output modules, like motors, servos, and lights, to perform the exact actions you programmed in the app.
Part 2. App Basics.
There are two versions of the CyberBrick app: desktop and mobile. Both versions let you import and customize existing configurations from MakerWorld. However, you will need the desktop app if you want to build an entirely new configuration from scratch for a custom remote or machine. When you open the desktop app, the homepage gives you two main options: New Project and Import Project. Selecting New Project lets you start with a completely blank canvas, or you can use a template based on an official CyberBrick design. For instance, if you open the flatbed truck template, you will see how the remote's transmitter maps to the physical buttons and joysticks on the official CyberBrick remote. Because this template is built to control the official truck, looking at any input module shows you exactly which output module it controls on the vehicle. As an example, if you look at the left joystick, or L stick, you can see that the Y-axis, which is moving the stick forward and backward, is mapped to an output module named throttle. If you then switch over to view the truck's motor options, you will find that throttle module along with all of its specific speed and behavior settings.
Part 3. Creating a configuration.
Let's recreate a config to control the CyberBrick official truck with the CyberBrick standard remote. First, create a new project and select Start from Blank. Right now, we're looking at an empty transmitter configuration named Remote. Our first step is to tell the software what is actually plugged into our physical remote. To do this, click on each module socket and select the module type connected to that socket. As a best practice, go ahead and name each module based on its location. Next, let's set up the truck. Click Add Receiver and confirm its name. When you select it, the receiver diagram will pop up. Just like we did with the remote, select the output modules based on where they are physically plugged into the vehicle's receiver. For our CyberBrick truck, we'll match the modules shown on screen. It's a great habit to name these modules based on what they actually do, like steering or headlights. Once you've assigned these modules to their sockets, you'll see them appear in the list on the left-hand side. This is where we adjust their behavior settings. Before we link the remote and the truck, let's tweak a few component settings. First, let's adjust the steering servo to match the truck's actual geometry. Under Angular Servo, find your steering servo. Change the minimum angle to 50 degrees and the maximum angle to 130 degrees. You may have also noticed a continuous servo option when adding transmitter modules. An angular servo corresponds with a 180-degree servo, which rotates to a specific angle and then automatically returns to 0. By contrast, a continuous servo spins freely much like a regular motor, but with much more precision. For example, a continuous servo is used to raise and lower the forks on the official forklift. Next, let's set up the headlights with a simple on and off function. Under LED, make sure you have two effects created: on and off. Since our headlights are plugged into LED slots 1 and 2, next to the on option, turn both of those sockets on. Set the mode to steady. LED events can be configured for more than just basic on and off functions. You can create flashing turn signals that sync up with your steering joystick. You can also create flashing hazard lights and reverse lights that automatically trigger along with throttle commands when the truck backs up. Feel free to load up the different official templates and look at the configurations in their receiver LED sections. Now that the remote and the truck are configured, we need to tell them how to talk to each other. Let's map our controls. Go back under the remote settings and select the left joystick. We want pushing this stick forward and backward to control the truck's speed. To do this, add a channel binding, select the Y channel, and link it to the throttle module. Because of how the motor is physically mounted in this truck, we need to set the direction to negative. If we left it as positive, pushing forward on the stick would actually make the truck drive backward. Now let's handle the steering. Select the right joystick. We want moving this stick left and right to turn the front wheels. Add a channel binding, select the X channel, and link it to the steering module. Just like the motor, the way this steering servo is installed happens to mean we need to set this direction to be negative as well. Finally, let's make the headlights turn on and off with the left shoulder button. Under left shoulder button, we're going to add an event. Set the trigger action to short hold, which just means a normal, quick button press. Select the lights module. Under value, add two distinct values, on and off. By adding both values, you're creating a cycle. Every time you tap that shoulder button, the software will switch to the next value in the list, in this case, turning the lights on and off. Part 4. Conclusion. With the basics of configuring transmitter and receiver module behavior under your belt, you're ready to customize your controls for existing designs, which can be found on MakerWorld. You could even delve into making and configuring your own CyberBrick creation using the information in the CyberBrick App Resource Center. You've got the tools, it's up to you to bring your next print to life. Want to keep learning? Visit Bambu Lab Academy at bambulab.com/academy.